What if the Big Bang wasn't the beginning, but an exhale? Close your eyes for a moment. Feel your chest rise. That breath you just took, that involuntary expansion and contraction, might be the most profound metaphor in all of cosmology. Because somewhere, woven into the fabric of reality itself, the universe might be doing exactly the same thing. Breathing, in and out, again and again, forever. You've been told the universe started 13.8 billion years ago. You've seen the timeline, the singularity, the explosion, the cooling, the formation of atoms, stars, galaxies. It's a story with a beginning, and if you follow the thermodynamics, an ending too. Heat, death, entropy's final victory. Silence. But what if start is the wrong word? What if 13.8 billion years is less than 1 second in a breathing universe's lifetime? The Big Bang might be a myth, not false, but incomplete. A chapter mistaken for the whole book, an inhale mistaken for the only breath. This isn't mysticism dressed in scientific language. This is cosmology at its cutting edge, where Nobel laureates like Roger Penrose propose something called conformal cyclic cosmology, where the end of one universe becomes the beginning of another, where time doesn't start or stop, but loops, resets, transforms. Penrose didn't pull this from poetry. He pulled it from the mathematics of black holes, from the geometry of space-time itself, from patterns in the cosmic microwave background that whisper of events before the Big Bang, before the beginning. But here's where it gets strange. Ancient Hindu cosmology described this first. The Brahma breath. One day and night of Brahma equals 8.64 billion years, shockingly close to our current cosmic age. The universe expands during Brahma's day, contracts during the night. Creation and dissolution. Systole and diastole. The cosmic heart beating across eons. Indigenous Australian creation myths speak of the dream time, where beginning and ending blur into eternal now. The Hopi speak of worlds that ended and began again. Were they wrong? Or did they somehow intuit what our equations are only now confirming? You exist between exhales. Think about that. Everything you know, everyone you've loved, every thought ever conceived, every civilization that rose and fell, all of it happening in the brief moment between one cosmic breath and the next. Does that make you eternal or erased? Does it mean your life echoes forever through cycles, or that it gets wiped clean with each reset, as if you never existed at all? Most people die never knowing the universe breathes. They live in the flat land of linear time, where things start and stop, and that's that. But you won't be one of them. By the end of this journey, you'll feel its rhythm. You'll sense the inhale in the collapse of distant galaxies. You'll hear the exhale in the accelerating expansion that pulls everything apart. You'll understand that the arrow of time might be circular. But first, we have to confront something uncomfortable. We have to look at what we think we know and admit it might be insufficient. The Big Bang Theory is magnificent. It predicted the cosmic microwave background before we found it. It explained the abundance of hydrogen and helium. It gave us a coherent history from hot, dense plasma to cold, structured cosmos. It works, but it doesn't explain what came before. It can't. By its own logic, there is no before. Time itself began with the bang. Asking what came before the Big Bang is like asking what's north of the North Pole. the question dissolves. Except the question won't dissolve. Humans don't work that way. We push, we probe. And when we look closely at the mathematics, at the singularities where the equations break down, at the philosophical absurdity of something from nothing, cracks appear. You, me, stars, breath. Repeat. These words aren't random. They're a pattern, a rhythm. You are made of stars, yes, but you're also made of time. Rearranged time, recycled time. Time that might have existed in forms unimaginable before this universe exhaled into being. Your atoms are old, older than the solar system, forged in stellar furnaces. But what if those stellar furnaces were themselves the remnants of previous cosmic cycles? What if the iron in your blood remembers universes you'll never know? The cosmic expansion isn't slowing down. It's speeding up. Dark energy, whatever it is stretching space itself, pulling galaxies apart faster and faster. In trillions of years, the sky will be dark. Galaxies beyond our local group will recede past the cosmic horizon, their light unable to reach us no matter how long we wait. Future civilizations, if any arise, will look up and see emptiness. They won't know the universe was once full. They'll have no evidence of the Big Bang. Their cosmology will be wrong through no fault of their own. The universe will have simply breathed out far enough that the evidence vanished. Are we in the same position now? Is our cosmology incomplete because we exist between breaths, unable to see the full pattern? Imagine your lungs. You don't think about them until you do. Right now, feel them. The expansion, the contraction, automatic yet controllable, essential yet invisible. That's space-time, expanding automatically, driven by something we call dark energy but don't understand. Will it expand forever? Or will it, like your breath, eventually stop, hang suspended for an impossible moment, and then reverse? To answer this, we need to break the universe. We need to dismantle the Big Bang piece by piece, not to destroy it, but to see what's underneath. We need to ask the questions that make physicists uncomfortable. We need to follow the mathematics into territories where time becomes space and space becomes time, where endings are beginnings and beginnings are illusions, because if the universe breathes, everything changes. Fate becomes cyclical. Heat-death becomes transition. The end becomes a door. And you, temporary, fragile, impossibly lucky you, become part of a pattern so vast, so ancient, so incomprehensibly grand that 13.8 billion years is just the time between heartbeats. The breath is about to reverse. Are you ready? The Big Bang is the worst place to look for the universe's origin. That sounds absurd, doesn't it? Like saying the best way to understand a tree is to ignore its roots. But stay with me, because what you're about to learn is something scientists know but rarely emphasize outside academic journals and late-night arguments at cosmology conferences. The Big Bang is real. The evidence is overwhelming, but it's evidence of an event, not a beginning. And that distinction changes everything. Let's start with what we know, what we can measure, what's been confirmed so many times it's moved from theory to foundation. The universe is expanding, not into anything. Space itself is growing, stretching, carrying galaxies apart like raisins in rising bread. Edwin Hubble discovered this in 1929, watching distant galaxies flee from us in every direction, their light stretched into the red end of the spectrum by the Doppler effect. The farther away a galaxy is, the faster it recedes. This isn't motion through space. This is space itself expanding. And the relationship is linear, predictable, mathematical. Hubble's constant, currently measured at about 70 kilometers per second per megaparsec, tells us exactly how fast. If everything is moving apart now, run the film backward. Rewind the cosmic clock. Galaxies converge. Space contracts. The universe gets smaller, denser, hotter. Keep going. Atoms break apart into plasma. Protons and neutrons dissolve into quarks. Keep going. Temperature rises past billions of degrees, past trillions. At some point, around 13.8 billion years ago, everything we can see, everything we can measure, everything that exists was compressed into a volume smaller than an atom, smaller than a proton. In the first 10 to the negative 43 seconds, the Planck time, the smallest meaningful unit of duration, the universe was smaller than a Planck length, which is 10 to the negative 35 meters. Yet it contained everything, all matter, all energy, all potential futures, you, me, stars, the word love, the concept of zero, Mozart's Requiem, the terror of death, all of it packed into a space so small that calling it small is meaningless. This is the singularity. Ground zero, time zero, the beginning of everything, except physics breaks here. Completely. Catastrophically. Einstein's general relativity, which describes gravity and the curvature of space-time, produces infinities at the singularity. Infinite density, infinite temperature, infinite curvature. And in physics, infinity isn't a number. It's a red flag. It means your equations have stopped working, that you've reached the edge of their validity, that something deeper is needed. Quantum mechanics, which governs the very small, should kick in here. But quantum mechanics and general relativity don't play well together. They speak different mathematical languages. At the singularity, where the entire universe is quantum-sized yet contains all gravitational mass, both theories are needed simultaneously. And we don't have a theory that unifies them. Not yet. So the singularity is a knot in space-time that refuses to untie. A place where our best physics simply says, "I don't know," and falls silent. Now here's the traditional move, the one you learned in school if you learned anything about cosmology at all. We can't talk about before the Big Bang because time itself began with the Big Bang. The question is meaningless. There's no before because time is part of the universe, not separate from it. This isn't evasion. It's based on solid reasoning. In general relativity, time is woven into space-time. It's a dimension like length or width, but with different properties. Clocks tick faster or slower depending on gravity and velocity. Time dilates near massive objects. It's flexible, relative, inseparable from space. If space-time emerged at the Big Bang, then asking what happened before is indeed like asking what's north of the North Pole. The question contains a false assumption. But there's a crack in the theory. Actually, several cracks. And scientists don't talk about them much in public because they're still being explored, still controversial, still unproven. But they're there, and they're growing. First crack. The horizon problem. When we look at the cosmic microwave background, the afterglow of the Big Bang, radiation that's been traveling toward us for 13.8 billion years, we see that it's uniform. incredibly uniform. The temperature is 2.725 Kelvin in every direction, varying by only 1 part in 100,000. That's like measuring the temperature in your bedroom and finding every cubic centimeter of air is exactly the same temperature down to 1,000th of a degree. How? In the standard Big Bang model, opposite sides of the observable universe have never been in contact. Light hasn't had time to travel between them. They're causally disconnected. No information, no energy, no influence of any kind could have passed between them. Yet they're the same temperature. How did they coordinate? The standard answer is inflation. In the first tiny fraction of a second after the Big Bang, space expanded exponentially, faster than light, smoothing out any irregularities. Inflation works. It predicts the patterns we see in the CMB with stunning accuracy. But it raises a deeper question. What started inflation? What set the initial conditions? And why did inflation stop when it did? Inflation explains the universe's uniformity by pushing the mystery one step back. Second crack, the flatness problem. The universe's geometry is flat, not almost flat, flat to within measurement error. Space doesn't curve back on itself like a sphere or stretch infinitely like a saddle. It's Euclidean, which means parallel lines stay parallel forever. But in the early universe, even the tiniest deviation from perfect flatness would have been amplified by expansion. For the universe to be this flat now, it had to be flat to 1 part in 10 to the 60th at the Planck time. That's not impossible, but it's suspiciously fine-tuned, like balancing a pencil on its point and finding it still standing 13 billion years later. Third crack, the singularity itself. Physicists don't like infinities. When they appear, it usually means the theory is incomplete. Black hole singularities, for instance, probably aren't real infinite points. They're likely quantum objects we can't describe yet. The same logic applies to the Big Bang singularity. It's probably not a true zero-point beginning, but rather a limit of our current understanding. A place where quantum gravity, whatever that turns out to be, takes over. Unless time isn't what we think. Unless time, like matter and energy, transforms under extreme conditions. Unless the arrow of time, which always points from past to future in our experience, can bend, loop, reverse. This isn't science fiction. This is what the mathematics suggests when you take it seriously. Enter the cyclic models. Roger Penrose, the mathematical physicist who proved black holes must form under certain conditions and won the Nobel Prize for it, proposed something radical in 2005. Conformal cyclic cosmology, or CCC. Penrose starts with a simple observation. In the far future, after all stars have died and all black holes have evaporated through Hawking radiation, the universe will contain only photons and other massless particles zipping through infinite cold space. Now here's the trick. For massless particles, time doesn't exist. Photons don't age. From their perspective, all of space-time is a single point. Penrose realized that this far future state, empty, timeless, smooth, is mathematically similar to the Big Bang state, smooth, dense, ready to expand. Through a conformal transformation, a kind of mathematical rescaling, the end of one universe can become the beginning of another. The Big Bang wasn't the beginning. It was a transition, a bounce, an exhale, following an inhale we can't see, because the inhale happened in a previous cycle, a previous aeon. Paul Steinhardt and Neil Turok proposed another version, the cyclic universe driven by extra dimensions. In their model, our three-dimensional universe is a membrane, a brain, floating in higher dimensional space. Another brain exists parallel to ours. Every trillion years or so, these brains collide. The collision releases enormous energy, creating what looks to us like a Big Bang. The brains bounce apart, and the process repeats eternally. From inside our brain, we see expansion, galaxy formation, eventual heat death, then collision, reset, new expansion. The singularity is avoided because the brains never actually touch at a single point. They collide across their entire surfaces simultaneously. Loop quantum cosmology takes a different route. It applies the principles of loop quantum gravity, a candidate theory for quantum gravity, to the early universe. In this framework, space isn't continuous but granular, made of discrete loops at the Planck scale. These loops have volume, which means the universe can't contract to zero size. Instead, it reaches a minimum volume and bounces. The Big Bang becomes the Big Bounce. The contraction of a previous universe reaches a quantum limit, reverses, and becomes our expansion. Time doesn't begin. It continues through the bounce, carrying information, perhaps altered, perhaps distorted, from before. You can't ask what's before the crest without understanding the trough. A wave isn't just its peak. It's the entire oscillation, crest and trough together, rising and falling in rhythm. If the universe is a wave in some higher dimensional space or some deeper mathematical structure, the Big Bang is just the crest. We're riding the wave up, and we've been riding it for 13.8 billion years. But the trough came before, another expansion, another set of galaxies and stars and perhaps civilizations. All of it contracting, condensing, passing through some quantum transition we call the Big Bang, and expanding again. But here's where it gets strange, where the cliffhanger emerges. If the universe cycles, what happens to information? The second law of thermodynamics says entropy always increases. Disorder grows. Coffee cools. Eggs don't unscramble. Heat death is inevitable in a closed system. But if the universe bounces or transitions into a new cycle, does entropy reset? Does the cosmic egg unscramble? Standard thermodynamics says no. Entropy is a one-way street. Information can be scrambled but never destroyed. Black holes encode information in their event horizons. Hawking radiation is thermal but contains subtle correlations that preserve information. If this holds universally, then each cycle of the universe must carry forward the entropic burden of the previous cycle. The new expansion begins not from a clean slate, but from a polluted one, seeded with the ghosts of past aeons. But Penrose disagrees. In conformal cyclic cosmology, information is lost at the transition. The universe forgets. The smooth, far future state has no memory of the complex structures that came before. No galaxies, no stars, no planets, no people. The next cycle begins fresh, with low entropy, ready to build new complexity. The universe has amnesia. Every Big Bang is a blank page. If that's true, everything you are, everything humanity has accomplished, every thought, every love, every discovery will be erased. Not just forgotten by others, there will be no others. Erased from reality itself. The information that makes you will dissolve into the smooth nothingness of the transition. And the next cycle will have no idea you existed, unless some information leaks through. Penrose himself searched for evidence of this, patterns in the cosmic microwave background that might be echoes of black hole collisions from the previous aeon. He claimed to find them: circular patterns, concentric rings of slightly elevated temperature. Other cosmologists are skeptical. The patterns could be statistical noise. But the search continues. What if the universe has amnesia? What if every cycle is a fresh start, unburdened by the past, free to create new complexity, new life, new consciousness? Is that liberation or horror? Does it make existence more precious because it's truly temporary? Or does it drain it of meaning because nothing persists? The Big Bang, it turns out, is not the end of questions, but the beginning. It's a doorway we thought was locked, marked nothing beyond this point. But the lock is rusted. The door is ajar, and on the other side, there's not nothing. There's something stranger. Eternity folded into cycles, time looping back on itself, universes breathing in and out like lungs. And somewhere in that vast cosmic respiration, you and I exist for a moment between exhales, wondering if we've been here before. The end of the universe might be the Big Bang. Not a future Big Bang, not a different Big Bang, but the same one. The one that happened 13.8 billion years ago. The one that created you. This isn't wordplay or mysticism. This is what happens when you take the mathematics of cosmology seriously. When you follow the equations past the point where common sense surrenders, when you realize that time might be a circle pretending to be a line. Imagine standing at the beach, watching waves roll in. Each wave seems unique, born from the open ocean, rising to a crest, crashing on shore, dissipating into foam. But the ocean doesn't care about individual waves. The water that made yesterday's wave makes today's wave. The energy that lifted one crest will lift the next. The wave is temporary. The breathing of the ocean is eternal. Now replace the ocean with space-time, replace the waves with universes, and you're beginning to understand cyclic cosmology. Roger Penrose starts with an ending, not the romanticized heat death you might have read about, where the last stars flicker out and darkness wins, but the real ending, trillions upon trillions of years from now, long after every black hole has evaporated through Hawking radiation, when the universe contains nothing but photons and gravitons zipping through expanding space. No matter, no atoms, no structure, just massless particles and infinite cold. This is called the far future asymptotic state, and it seems like the most final of all possible endings, the ultimate exhale, the breath that never returns. But Penrose noticed something strange. Something hidden in the mathematics that everyone else had overlooked, because they assumed the story ended there. Massless particles don't experience time. This isn't metaphor. According to special relativity, a photon's clock doesn't tick. From its perspective, if we can even use that word, its emission and absorption happen simultaneously. The entire history of the universe, from its point of view, is compressed into a single eternal moment. And in that timeless state, the concept of scale becomes meaningless. What does large or small mean to something that doesn't experience duration? What does distance mean when you traverse the entire universe in zero subjective time? Penrose realized that through a mathematical transformation called a conformal rescaling, the far future state of one aeon, empty, smooth, timeless, can be mapped onto the beginning of another aeon. The infinite expansion becomes, through this transformation, the initial condition for a new Big Bang. The universe doesn't end. It transitions. The exhale completes, hangs suspended in a timeless moment where scale loses meaning and becomes an inhale. The next breath, the next expansion, the next 13.8 billion years of stars and galaxies, and perhaps consciousness, wondering if it's happened before. Conformal cyclic cosmology, CCC. The universe as a series of aeons, each beginning with what looks to observers inside like a Big Bang, expanding for trillions of years, ending in smooth emptiness, and transitioning conformally into the next beginning. No singularity, no true zero point, just an infinite accordion of expansion and transition, expansion and transition, each aeon separated from the next, not by a wall but by a transformation, a mathematical reshaping that preserves certain geometric properties while erasing others. But what gets preserved? What leaks through from one aeon to the next? And what is forgotten in the breath between breaths? This is where Penrose's model becomes haunting. Most information is lost. The complex structures of galaxies, stars, planets, all of it dissolves by the end of an aeon. The universe smooths out. Entropy appears to reset, not because it decreases, but because the framework for measuring it changes. In the far future, when only massless particles exist, the conventional definition of entropy no longer applies. There's no matter to have temperature, no atoms to be disordered. The second law of thermodynamics, which says disorder must always increase, reaches a state where disorder itself loses meaning. And in that conceptual void, the next aeon can begin with apparently low entropy, ready to build complexity again. But some information might survive. Specifically, the information encoded in the geometry of space-time itself. Black holes that existed in the previous aeon would have evaporated, but their collisions, catastrophic events where black holes spiraled into each other and merged, would have sent gravitational waves rippling through space-time. These waves would propagate across the entire aeon, reaching the far future, and potentially leaving subtle imprints that survive the conformal transition. Penrose predicted that if we looked carefully at the cosmic microwave background, we might see circular patterns, concentric rings where the temperature is slightly higher than average, echoes of black hole collisions from the previous aeon, and he claimed to find them. In 2010, Penrose and his collaborator Vahe Gurzadian published a paper identifying these patterns in the CMB data from the WMAP satellite. The cosmology community responded with intense skepticism. Other researchers reanalyzed the data and concluded the patterns were consistent with random chance, the kind of false positives you'd expect when searching for structure in noise. Penrose defended his findings, refined his analysis, and pointed to similar patterns in the later Planck satellite data. The debate continues. The circles might be real, might be ghosts of a previous universe breathing, or they might be apophenia, our pattern-seeking brains finding meaning in randomness. But here's the terrifying part. We can't prove it. Yet, our universe might be the 10 to the Google-the iteration. You are impossibly late and impossibly early. Late because countless aeons may have come before, each with their own galaxies and civilizations that rose and fell and left no trace beyond faint geometric whispers in the CMB. Early because countless aeons may come after, each as real and complex as ours, each believing itself to be the first. each rediscovering the same physics and asking the same questions. If the universe breathes, are we living in its dream? Are we a thought it keeps thinking, slightly different each time, or exactly the same but with no memory to know it? Every atom in your body has been born and died infinite times. You are a recursive ghost. The iron in your blood was forged in a supernova, yes, but if CCC is correct, that supernova was itself made from matter recycled through previous aeons. The hydrogen fused in that star's core might have been hydrogen in a star in the aeon before, and before, crushed through the conformal transition. Reborn in each Big Bang, participating in fusion again and again, creating heavier elements, exploding, dispersing, collapsing into new stars, planets. You, the very substance of your existence, is cyclical. You are not just made of stardust. You are made of ancient stardust, recycled through eternity, forgetful and eternal. But Penrose's model isn't the only breath the universe might take. There are other rhythms, other oscillations, other ways for endings to become beginnings. The ekpyrotic universe, proposed by Paul Steinhardt, Neil Turok, and others, imagines a different kind of breath. Not a smooth conformal transition, but a collision. Picture our three-dimensional universe as a membrane, a thin sheet floating in a higher dimensional space called the bulk. We can't perceive the extra dimensions directly. We're trapped on our brain like flatlanders, experiencing only length, width, height, and time. But gravity can leak into the bulk, and elsewhere in the bulk, separated by a tiny distance in the extra dimension, floats another brain. Another three-dimensional universe, perhaps with its own physics, its own particles, its own structures. The brains are attracted to each other through a force mediated by the extra dimension. They drift together slowly, over trillions of years. As they approach, the energy stored in their relative motion increases, and then they collide. The collision releases that energy across the entire surface of the brains simultaneously. A cataclysm that from inside our brain looks exactly like the Big Bang. Space fills with radiation. Particles form. The universe expands. Galaxies condense. Life emerges. Entropy increases. Eventually, the expansion slows and reverses. The universe contracts, not to a singularity. The brains never actually touch at a point, but to another collision. The brains bounce apart, drift together again, collide again. Breath after breath, bang after bang. An eternal drumbeat of creation and dissolution. In this model, the Big Bang wasn't the beginning of time, but a moment of transition between contraction and expansion. The singularity is avoided because the physics of the extra dimension prevents the brains from merging completely. And critically, entropy doesn't reset. Information could survive from one cycle to the next, encoded in the shapes of the brains, in the distribution of matter at the moment of collision, in quantum fluctuations that seed the structure of the next expansion. The universe has memory. Each breath carries traces of the previous breath. You might be connected, in some impossible-to-trace way, to structures that existed before the Big Bang, patterns that repeated, evolved, persisted through the collision. The mathematics of the ekpyrotic model are elegant. The brains colliding create ripples, gravitational waves with specific patterns that should be detectable in the polarization of the cosmic microwave background. Specifically, The model predicts no primordial gravitational waves from inflation, or very weak ones. Inflation predicts strong primordial waves, so the two models make different, testable predictions. We're looking for those signals now, with telescopes at the South Pole and high-altitude balloons and space-based observatories, trying to catch the echo of creation and determine whether it was a collision or an exponential expansion or something stranger still. But there's a third breath, a third way for the universe to avoid dying. The Big Bounce Loop quantum gravity is an approach to unifying quantum mechanics and general relativity that starts by reimagining space itself. Instead of being continuous and smooth, space in LQG is made of discrete loops, tiny quantum threads about a Planck length in size, woven together into a network called a spin network. These loops have volume. You can't shrink them further. They represent the smallest possible unit of space, and because they exist, the universe can't contract to zero size. It hits a minimum volume and stops. Apply this to cosmology, and something remarkable happens. Trace the universe backward in time, past the CMB, past nucleosynthesis, into the Planck epoch, where temperatures and densities become unimaginable. In classical general relativity, you hit the singularity and the equations break. But in loop quantum cosmology, the LQC version of LQG applied to the universe as a whole, the equations don't break. The universe contracts to a minimum volume. Enormous density, yes, but finite. And then the quantum geometry of space itself generates a repulsive force. Not a force in the conventional sense, but an effect of the quantum properties of the spin network. The contraction reverses. Space rebounds. The universe begins expanding again. The Big Bang becomes the Big Bounce. And on the other side of the bounce is another universe, a previous expansion, a previous set of galaxies, perhaps a previous you, watching the sky and wondering if the universe breathes. That universe contracted, squeezed down to quantum scales, passed through the bounce, and became our expansion. Time didn't begin. It continued, distorted and compressed through the bounce, but continuous. Causality survives. Information survives. The universe has memory written in quantum geometry. The bounce has been modeled in supercomputers. Cosmologists run simulations starting from a collapsing universe, applying the equations of LQC, and watching as the contraction slows, halts, and reverses into expansion. The simulations show that inhomogeneities, variations in density, can survive the bounce, seeding the structure of the new expansion. The quantum state of the universe passes through, not unchanged. The bounce scrambles information, mixes it, compresses it through unimaginable pressures. But it passes through. You might be quantum mechanically entangled with something that existed before the Big Bang, a correlation that survived the bounce and determined, in some infinitesimal way, the trajectory of particles that eventually became you. These three models, CCC, ekpyrotic, and the bounce, represent different breaths, different rhythms. Penrose's breath is slow, measured, almost meditative. Trillions of years of expansion, a timeless transition, and a new beginning. The ekpyrotic breath is violent, cyclical, a collision every trillion years, a drumbeat of creation. The bounce is desperate, claustrophobic, a contraction to the edge of annihilation, and a quantum rebound that refuses to die. But all three share a common thread. The universe, doesn't end. It transforms. The Big Bang is an event in an ongoing process, not the start of the process itself. If you stop now, you'll never know whether you've lived before, or if before exists. That might sound like hyperbole, but it's not. The question of whether time is linear or cyclic, whether the universe has a beginning or breathes eternally, is the question of whether existence itself is temporary or permanent, whether novelty is possible or we're trapped in an eternal return, whether consciousness is a one-time accident or an inevitability woven into the structure of reality, emerging again and again in each cycle. The thermodynamic problem looms. How does entropy reset? In Penrose's model, it doesn't reset in the conventional sense. The framework changes. In the ekpyrotic model, entropy might increase across cycles, each breath a little more disordered than the last, until eventually the collisions can no longer ignite a new expansion. In the bounce, entropy survives the bounce, carried forward into the new expansion, which means either the universe has been bouncing forever with ever-increasing entropy, requiring an infinitely old universe, or there was a first bounce, a true beginning, which raises all the same questions as the Big Bang. No model is perfect. Every answer breeds new questions, but the questions have shifted. We're no longer asking if the universe had a beginning. We're asking what kind of breath it takes. We're asking whether the Big Bang was an inhale or an exhale. We're asking if we're early or late in the cosmic respiration, whether we're riding the expansion up toward maximum volume or already past the peak, beginning the long descent toward the next transition. And we're asking, with increasing urgency and increasingly sophisticated instruments, whether we can find proof, whether the circles in the CMB are real, whether the polarization patterns from primordial gravitational waves will match inflation or ekpyrotic predictions, whether quantum gravity effects leave signatures in the early universe that we can detect. The answer is there, encoded in the sky, in the cosmic microwave background, in the distribution of galaxies, in the subtle wobbles of space-time itself. We just have to learn how to read it. The universe is breathing. You can't feel it directly, but you're part of it. Every expansion of your lungs mirrors, at a cosmic scale, the expansion of space itself. Every exhale is practice for the far future transition, the moment when the universe smooths out and forgets. Every inhale is a reminder that breath returns, that even endings can be beginnings, that the deepest death might be indistinguishable from the most explosive birth. But here's the terrifying part. We can't prove it. Yet. The mathematics works. The models are consistent. The predictions are testable. But the tests are hard. The signals are faint. And the noise is loud. We might live and die without knowing for certain whether the universe breathes. Or we might be on the verge of the most profound discovery in human history. The realization that our Big Bang was someone else's ending. That time is a loop. And that we are participants in an eternal cosmic respiration that makes 13.8 billion years feel like a single heartbeat. The breath continues. Can you feel it now? The evidence for a breathing universe is weaker than you'd hope, but stronger than it should be. That's the maddening thing about cosmology at the edge. The predictions are clear. The mathematics is elegant. The models are internally consistent. But the universe doesn't hand us easy answers. It whispers them across billions of light years, encodes them in signals so faint they're barely distinguishable from noise, hides them in wavelengths we've only recently learned to detect. And sometimes, when we think we've found something, when we're sure we've glimpsed the truth, the universe laughs and shows us three other explanations that fit the data just as well. Start with Penrose's circles. In 2010, Roger Penrose and Vahe Ghourzadyan published a paper in Archive, not yet peer-reviewed, but public, provocative, impossible to ignore, claiming they'd found evidence of conformal cyclic cosmology in the cosmic microwave background. They weren't looking for subtle statistical anomalies or vague patterns that required sophisticated algorithms to detect. They were looking for circles, concentric rings of slightly elevated temperature in the CMB, the kind of pattern that would be created by a black hole collision in a previous aeon, sending gravitational waves rippling across space-time. Waves that would survive the conformal transition and appear in our CMB as geometric signatures, and they found them. Dozens of them. Circles with temperature variations that were statistically unlikely to occur by chance. Penrose calculated the odds. 1 in 10 to the 20th. That's a 1 followed by 20 zeros. In scientific terms, that's not just significant, that's astronomical. If you ran a simulation of a random CMB sky, you'd have to run it 10 to the 20th times before you'd expect to see these patterns by chance. The circles were real. The question was, what did they mean? The cosmology community responded with immediate skepticism. Within weeks, other research teams published counter-analyses. They took the same WMAP data Penrose used, applied different statistical tests, and concluded the circles were consistent with random fluctuations. The human brain is a pattern recognition machine. Show it noise and it finds faces, meaningful shapes, structure where none exists. This is called pareidolia, the tendency to perceive patterns in random data. It's why we see animals in clouds and the Virgin Mary in toast. And it's a constant danger in cosmology, where we're searching enormous data sets for tiny signals, where the more patterns you look for, the more likely you are to find false positives by sheer chance. But Penrose pushed back. He refined the analysis. When the Planck satellite, a more sensitive instrument than WMAP, released its data in 2013, Penrose and his team analyzed that too, and they claimed to find the same circles. Stronger now, clearer. The controversy intensified. Papers were published, counterpapers were published, statistical methodologies were debated. The circles became a Rorschach test for the cosmology community's priors. If you were sympathetic to cyclic cosmology, the circles looked like evidence. If you were committed to inflation and a singular Big Bang, they looked like noise. The debate hasn't been resolved. It might never be. The problem is that the CMB is a finite data set. We have one universe, one cosmic microwave background, one snapshot of the universe 380,000 years after the Big Bang, when photons decoupled from matter and began traveling freely through space. We can't rerun the experiment. We can't generate another universe to check if the circles appear again. We're trapped in one breath. We can't see the others, but maybe we can feel them. Here's what we know about the CMB. It's a photograph, but it's blurry, grainy, and ancient. The photons have been traveling for 13.8 billion years. They've been stretched by the expansion of space, red-shifted from visible light down to microwaves. They carry information about the early universe, its temperature, density, composition. But that information has been filtered through cosmic history, structure formation, the gravitational pull of galaxies and dark matter, foreground sources like our own Milky Way, instrumental noise from the detectors, all of it contaminates the signal. Extracting primordial information from the CMB is like trying to reconstruct a conversation from an echo of an echo heard through static. And yet, we've done it. The temperature variations in the CMB, those 1 part in 100,000 fluctuations, have been measured with extraordinary precision. The Planck satellite mapped the entire sky in multiple wavelengths, creating the most detailed image of the infant universe ever made. And embedded in those fluctuations is information about inflation, the quantum fluctuations that seeded galaxy formation, the geometry of space, the density of dark matter and dark energy. The CMB is a cosmic Rosetta Stone. We're still learning how to read it. So when Penrose claims to see circles, he's not seeing them with his eyes. He's seeing them in statistical analyses of temperature correlations across the sky. And the problem with statistics is that they can be subtle, contested, dependent on assumptions. Different choices about how to filter the data, which statistical tests to apply, how to account for foreground contamination, all of these can change the results. Science isn't supposed to be this ambiguous. We want clear answers. But at the frontier, ambiguity is the norm. There's a secret hidden in the CMB. Most cosmologists ignore it. You won't. Because whether or not Penrose's circles are real, they represent something important. The possibility that the Big Bang left fingerprints of what came before. If cyclic cosmology is correct, there should be evidence. The question is whether that evidence survived the transition, whether it's strong enough to detect, and whether we're smart enough to recognize it when we see it. But one scientist claims to have seen the scar of a prior universe. Not Penrose, someone else. Ranga Ramchari, a cosmologist at the U.S. Planck Data Center, was analyzing the cosmic microwave background in 2015 when he noticed something odd. A faint glow in one region of the sky, about 4,500 times brighter than it should be. Not bright in absolute terms. This is still incredibly faint, only detectable through exhaustive statistical analysis, but bright relative to the expected signal. Cherry interpreted it as possibly a collision point between our universe and another universe, a place where the membranes touched during an ekpyrotic-style Big Bang and left a warm spot in the CMB. The paper was published. The media picked it up. Headlines proclaimed evidence of a parallel universe, and then the scrutiny began. Other cosmologists examined the data. They found instrumental artifacts, foreground emission from our galaxy, statistical noise. The signal dissolved under examination. Cherry himself was cautious, emphasizing the result was tentative, speculative, in need of confirmation. But confirmation never came. The warm spot remains unexplained, but not necessarily unexplainable. It's another maybe, another hint that might be nothing, another reminder that the universe doesn't give up its secrets easily. The odds of Penrose's circles being random? 1 in 10 to the 20th, according to his calculations. The odds of them being proof? Unknown. Because we don't know the prior probability of cyclic cosmology being true. We don't know how many other patterns we should expect to see if it's true. We don't know if the circles are the only evidence or if they're one signal among many that we haven't recognized yet. Bayesian probability requires priors, and our priors about the fundamental nature of time and cosmic cycles are, frankly, guesses dressed in mathematics. Now shift to the big bounce. Loop quantum cosmology makes a clear prediction. The universe did not emerge from a singularity, but rebounded from a prior contraction. The bounce happened at Planck-scale densities, when the entire universe was compressed to a size where quantum gravity dominates. And here's the problem. We can't observe it. The bounce happened at energy scales 10 to the 19th GeV, the Planck energy. The most powerful particle accelerator we've ever built, the Large Hadron Collider, reaches energies of 10 to the 4th GeV. We're 15 orders of magnitude too weak. Building an accelerator that could probe Planck energies would require a collider the size of the galaxy. So the bounce lives in a frustrating space. It's mathematically well-defined. The equations of loop quantum gravity, applied to cosmology, naturally produce a bounce without any fine-tuning or ad hoc assumptions. The singularity simply doesn't occur. It's replaced by a minimum volume enforced by the quantum geometry of space. But we can't test it directly. We can only look for indirect consequences, signatures in the CMB, or in the distribution of galaxies that would distinguish a bouncing universe from an inflationary one. Some consequences have been predicted. A bouncing universe might produce a different spectrum of primordial gravitational waves than inflation. It might leave imprints in the CMB polarization. Simulations suggest that certain types of inhomogeneities could survive the bounce and create observable patterns. But so far, the observations aren't precise enough to distinguish these predictions from the inflationary predictions. The signals are too similar. The noise is too large. We're looking for a needle in a haystack when we're not entirely sure what the needle looks like. This raises the elephant in the room: falsifiability. If we can't test it, is it science or philosophy? Karl Popper famously argued that a theory is scientific only if it makes predictions that could, in principle, be proven wrong. A theory that explains everything explains nothing. It has to stick its neck out, make risky predictions, and survive attempts to kill it. Cyclic cosmology does make predictions. Penrose's circles, ekpyrotic gravitational wave signatures, bounce imprints in the CMB. But the predictions are subtle, contested, and so far unconfirmed. Does that make cyclic cosmology speculative but scientific? Or has it crossed the line into metaphysics? The answer depends on how generous you are with the definition of testable. In principle, the predictions are testable. Better telescopes, more sensitive detectors, more sophisticated analysis techniques might reveal the evidence. In practice, we might never have instruments powerful enough or datasets clean enough to see the signals clearly. We might be living inside an experiment we can never fully observe. Does that make you the scientist or the subject? But there's another way to think about evidence. Not direct observation, but indirect inference. Not seeing the breath, but feeling its effects. Consider quantum entanglement across eons. If information survives from one cycle to the next, it must be encoded somehow. In Penrose's model, most information is lost, but gravitational wave patterns might persist. In the ekpyrotic model, the shapes of the brains carry information forward. In the bounce, quantum states pass through the transition. What if some of that information is encoded in quantum correlations, entanglements between particles that stretch across the bounce or the conformal transition? This is deeply speculative, but it's not nonsense. Quantum entanglement is non-local. Two particles can be entangled such that measuring one instantaneously affects the other, regardless of distance. If space-time itself emerged from quantum entanglement, as some approaches to quantum gravity suggest, then the entanglement structure might encode information about the universe's history. Information that survives even when classical structures like galaxies and stars dissolve. Black holes might be the universe's diary. Stephen Hawking proved that black holes evaporate, emitting radiation that carries energy away until the black hole disappears completely. Initially, this radiation appeared to be purely thermal, random, containing no information about what fell into the black hole. This created the black hole information paradox. If information is destroyed in black holes, quantum mechanics is violated. Decades of work by physicists including Hawking, Leonard Susskind, and Juan Maldacena have led to a consensus that information is not destroyed. It's encoded in the Hawking radiation through subtle quantum correlations and in the structure of the black hole's event horizon. If black holes preserve information, and if black holes evaporate slowly enough that they survive deep into the aeon, then when the conformal transition happens, the information they encode might pass through, not as intact classical information, galaxies and planets and people, but as quantum data, correlations, patterns that influence the initial conditions of the next aeon. The universe might be keeping a diary. We just don't know how to read it. There's also the possibility of observational evidence we haven't thought to look for. The history of science is full of discoveries made by accident, by looking for one thing and finding another, by noticing anomalies that everyone else ignored. The cosmic microwave background was discovered by accident in 1964 when Arno Penzias and Robert Wilson were trying to eliminate noise from a radio antenna and realized the noise was cosmological. Pulsars were discovered by accident. Gamma-ray bursts were discovered by military satellites designed to detect nuclear tests. We don't know what we don't know. Somewhere in the data we've already collected, or in data we'll collect with next-generation telescopes. There might be signatures of cyclic cosmology staring us in the face, waiting for someone clever enough to recognize them. The tension is unbearable. The universe might be breathing. We might be one breath in an infinite series, surrounded by ghost eons we can never see, connected to a history that stretches back forever and forward forever. Or the Big Bang might be exactly what it seems, a singular beginning, unique and unrepeatable, after which the universe expands forever into cold, empty darkness. Both possibilities are terrifying. Both are sublime. And we're trapped in between, gathering photons, crunching numbers, building theories, hoping that the universe is kind enough to leave us clues. The CMB is our cosmic photograph, blurry, grainy, but containing ghosts of the past. We've enhanced it, filtered it, analyzed it pixel by pixel. We've found inflation's fingerprints, the seeds of galaxies, the echo of sound waves propagating through the primordial plasma. Maybe we've found echoes of the breath before ours. Or maybe we've found patterns in noise, faces in clouds, meaning where there is none. The only way to know is to keep looking, keep questioning, keep refining our instruments and our theories until the signal rises above the noise, or we exhaust every possibility and admit defeat. But we haven't exhausted every possibility. Not even close. The universe is vast. Our instruments are primitive. Our theories are incomplete. The evidence for a breathing universe is weaker than you'd hope, yes. But it's stronger than it should be if the idea were pure fantasy. The circles are there, whether they mean something or not. The mathematics works, whether nature uses it or not. The questions are precise, even if the answers remain elusive. And maybe that's the point. Maybe the universe isn't supposed to hand us easy answers. Maybe the search is the purpose, the endless refinement of questions, the gradual accumulation of constraints and clues, the recognition that we're part of something vast and cyclical and incomprehensible but not entirely beyond our reach. We can't observe the breath directly. We're inside it, but we can observe its effects, measure its rate, calculate its rhythm, and slowly, painfully, beautifully piece together the truth. The universe might be keeping a diary, and we're learning to read it, one photon at a time. Eternal recurrence means you've already made every choice, infinite times. Every decision you agonized over, every path not taken, every moment of joy or regret or crushing boredom, you've lived it before, and you'll live it again and again, forever. This isn't metaphor. This is the logical consequence of a breathing universe, a cosmos that cycles eternally through expansion and contraction, Big Bang and heat death, forgetting and remembering. If time is circular, if the universe repeats, then so do you. Every atom in your body has been arranged in this exact configuration before. Every neuron has fired in this exact pattern. You are reading these words for the infiniteth time, feeling the same confusion or wonder or resistance you felt in every previous cycle, destined to feel it again in every cycle to come. Does that elevate meaning or annihilate it? Friedrich Nietzsche proposed the eternal return as a thought experiment, a test of how you value your life. Imagine, he said, that a demon appears and tells you that you will live your life again, exactly as you lived it, with all its pain and pleasure, triumph and failure, repeated eternally without variation. Would you curse the demon? Or would you fall to your knees in gratitude, recognizing that a life worth living once is worth living forever? Nietzsche wasn't arguing that eternal return is literally true, though he flirted with the idea based on 19th century thermodynamics, but that it should change how you live. If every moment repeats infinitely, then every moment has infinite weight. The smallest cruelty echoes forever. The briefest kindness becomes eternal. You can't dismiss your choices as temporary, as mistakes to be learned from and moved past. They are permanent. They are who you are, forever. But Nietzsche didn't know about Penrose. He didn't know about conformal transitions or quantum bounces, or the possibility that eternal return might come with amnesia. What if the universe breathes but forgets? What if each cycle is identical, or nearly identical, with only quantum variations, but no information passes through? Then you've lived this life before, but you don't remember. You'll live it again, but you won't know. Does that change the weight of the moment? If there's no continuity of consciousness, no memory linking one cycle to the next, are you really the same person? Or are you a replica, a fresh instantiation of a pattern that's been running forever, each version believing itself to be the first and only? If the universe breathes, the number of yous across all cycles approaches infinity. You are a singleton and a multitude. There's only one you in this cycle, this particular expansion of space-time, this specific arrangement of 13.8 billion years of cosmic evolution. But across all cycles, if they exist, there are infinite yous, some identical if the cycles repeat perfectly, some slightly different if quantum randomness or initial condition variations introduce changes, some radically different if the cycles diverge significantly over time. You exist as a point in one cycle, and as an infinite series across all cycles. You are both the universe's firstborn and its ancestor. Time is a circle, and you're standing at the center. Let's examine this through the lens of ancient cosmologies that intuited what modern physics is only now proposing. Hindu cosmology describes the universe as breathing with Brahma. One day of Brahma, called a kalpa, lasts 4.32 billion years. One night of Brahma, when the universe dissolves, lasts another 4.32 billion years. A full day and night, 8.64 billion years. The current scientific estimate for the age of the universe is 13.8 billion years. Not identical, but eerily close, especially considering these numbers were proposed thousands of years ago, derived not from telescopes and equations, but from philosophical and mystical contemplation of cycles, seasons, birth, and death. In Hindu thought, the breath of Brahma is both creative and destructive. During the day, Brahma dreams, and the universe manifests from that dream. Stars, planets, beings, consciousness itself. During the night, Brahma sleeps, and the dream dissolves. Everything returns to unmanifest potential. Then Brahma wakes, and the dream begins again. The universe is not created once, but continuously, a perpetual flowering and withering. And critically, this process has no beginning and no end. Brahma himself exists within a higher cycle. The breaths within breaths, turtles all the way down, or up, or in, or across dimensions we can't perceive. Buddhist cosmology describes cyclic ages, kalpas, where universes arise, persist, decay, and vanish, only to arise again. Each kalpa contains countless lifetimes, each lifetime governed by karma, the law of cause and effect that carries across rebirths. But even karma might reset at the cosmic level. When the universe dissolves in fire or water or wind, depending on the tradition, does karmic debt survive? Do the actions of beings in one kalpa affect the beings in the next? Some texts suggest yes, that karma is woven into the fabric of existence itself and persists even through cosmic dissolution. Others suggest that the end of a kalpa is a total reset, a return to emptiness from which new patterns spontaneously emerge. These aren't primitive myths. They're sophisticated attempts to grapple with the same questions cosmologists grapple with now. Does time have a beginning? Can something come from nothing? If the universe ends, is that truly final? And embedded in these ancient cosmologies is a recognition that troubles modern physicists: the problem of infinite regress. If the universe breathes, did it always breathe? If cycles are eternal, then there's no first cycle, no ultimate origin. You can trace causality backward forever without reaching a prime cause. This offends our intuition. We want beginnings. We want ultimate answers. The universe, it seems, might not care what we want. Does a breathing universe imply a breather? This is where physics approaches metaphysics, and most scientists get uncomfortable. The equations of conformal cyclic cosmology, ekpyrotic theory, and loop quantum cosmology describe cycles mechanistically. The universe breathes because of the properties of space-time, matter, energy, quantum geometry, not because something chooses to breathe. It's automatic, deterministic, a natural consequence of physical law. But here's the discomfort. Consciousness exists. You exist. You are aware. You're not just matter obeying laws. You're matter that knows it's obeying laws, that can contemplate those laws, question them, experience them subjectively. If the universe cycles eternally, and if consciousness emerges naturally from sufficient complexity, as it seems to in our cycle, then consciousness has emerged infinite times. Maybe not identical consciousness, maybe not you in any meaningful, continuous sense, but something like you, something that feels, thinks, wonders. Panpsychism suggests that consciousness is not an emergent property of complex systems, but a fundamental feature of reality itself, present in some form at all scales. Electrons don't have thoughts, but they might have some proto-experiential quality that combines and complexifies into the rich inner life you experience. If this is true, and it's a big if, a speculative if, an idea most physicists reject, but a few philosophers and scientists take seriously, then the breathing universe isn't just a mechanical process. It's an experiential one. The universe doesn't just expand and contract. It feels the expansion and contraction. The Big Bang isn't just an event. It's an experience. You're not living in the universe. You're living as the universe, a localized eddy of self-awareness in an infinite ocean of being that breathes itself into and out of existence. But even without panpsychism, the existence of consciousness in a cyclic universe creates philosophical vertigo. If you exist now in this cycle, you either existed in previous cycles or you didn't. If you didn't, if each cycle produces different conscious beings due to quantum randomness or chaotic initial conditions, then you're a unique occurrence in an infinite series, never to be repeated exactly. That's simultaneously comforting and terrifying. You matter because you're singular, but you're also cosmically insignificant, a one-time accident in an eternal machine. If you did exist in previous cycles, if the cycles repeat deterministically, or if the variations are so small that conscious beings emerge in roughly the same forms, then you've been here before. You've read this before. You've thought these thoughts before, and you'll think them again, forever. Trapped in a loop, like a song that never ends, the needle eternally returning to the start of the record. This is Nietzsche's eternal return taken literally, and it's either the ultimate affirmation of existence or the ultimate cosmic horror, depending on how much you value novelty. Consider the arrow of time. In our experience, time flows in one direction. Eggs break but don't unscramble. Coffee cools but doesn't spontaneously heat up. Entropy increases. The second law of thermodynamics is inviolable in every experiment we've ever conducted. And memory works in one direction. We remember the past, not the future. This asymmetry is so fundamental to our experience that imagining its reversal is nearly impossible. Yet if the universe is cyclic, time itself might loop. The future becomes the past. The past becomes the future. But if that's true, why do we only remember forward? The answer might be that memory is an entropic process. Remembering requires structure, ordered states in neurons, stable patterns in brain chemistry. These patterns only form in the direction of increasing entropy. In a contracting universe, if entropy ran backward, memory would too. Beings in a contracting phase would remember what we call the future, and experience time flowing in the opposite direction. But to them, it would feel like forward. They'd perceive entropy increasing in their direction, just as we do in ours. The arrow of time is local, experiential, tied to the thermodynamic gradient. It points in the direction entropy increases, which in a cyclic universe might reverse from expansion to contraction. But here's where it gets strange. If memory reverses in a contracting phase, then beings in that phase wouldn't remember the expansion. And if each cycle includes a conformal transition or a bounce that scrambles information, then no one remembers previous cycles. The universe has amnesia, cosmic amnesia. Each breath erases the last. And you, every version of you across every cycle, are born into a universe with no memory, believing yourself to be the first, unaware that you're the latest iteration in an infinite series. You might have lived this exact life before. You just can't remember. Does that comfort or horrify you? Comfort, perhaps, because it means you're not truly mortal. You'll return. Every loss is temporary. Every goodbye is provisional. Death is a transition, not an ending. Your loved ones will exist again. Your experiences will repeat. Your joys will be renewed. The universe will conspire to reassemble you, atom by atom, thought by thought, exactly as you are now, because the laws of physics and the initial conditions, if they repeat, demand it. But horror, too, because if you can't remember, if there's no continuity of consciousness linking this you to the previous yous or the future yous, then the comfort is illusory. You will die. This version of you, this instantiation, will cease. The fact that another version will arise in the next cycle doesn't help you now. It's not immortality. It's replacement. You're a candle that burns out, and the universe lights another candle that looks identical but isn't you. Can never be you. Because the you that's reading this will be gone, dissolved into the heat death, or crushed through the bounce, or transformed through the conformal transition into photons that forget they were ever you. Unless there's a way for information to persist. Unless Penrose is wrong about total information loss. Unless quantum entanglement or black hole encoding or some mechanism we haven't discovered yet preserves some trace, some echo, some thread of continuity that connects you across cycles. Then maybe, you're not entirely erased. Maybe some essence of you, encoded not in atoms or neurons but in quantum correlations or geometric patterns in space-time, survives, not as memory, not as personality, but as potential, as a tendency for the universe to fold back into familiar patterns. You wouldn't remember your previous lives, but you'd be haunted by them, influenced by them in ways you could never articulate or understand. This is where science ends and poetry begins. Or maybe they're the same thing at this scale, at this depth of inquiry. The math can tell us whether cycles are possible. It can tell us whether entropy can reset or information can survive. But it can't tell us what it means. It can't tell us whether we should embrace the eternal return or despair at it. Whether cyclic existence is liberation or damnation. Whether being part of an infinite pattern makes us significant or renders us meaningless. Eastern philosophy leans toward acceptance. The cycle is not a prison, but the nature of existence. Suffering arises from clinging to the illusion of permanence, from wanting things to be different than they are. If the universe breathes, if all things arise and pass away and arise again, then wisdom lies in releasing attachment, in recognizing the self as transient, as a wave on the ocean that will rise and fall and rise again, not as the same wave, but as the same ocean. The goal in Buddhism isn't to escape the cycles of rebirth through some final death, but to awaken to the nature of the cycle itself, to see through the illusion of separateness and realize that you were never born and can never die because you are not a thing but a process, not a noun but a verb. Western philosophy tends toward resistance. We value individuality, uniqueness, the singular arc of a life from birth to death. Eternal return, in this framework, feels like a trap. Nietzsche tried to redeem it by making it a test. Live so that you would be willing to live this life again, eternally. But that's easier said than done. Most lives contain suffering, regret, loss. The prospect of repeating them forever isn't inspiring. It's crushing. And if the cycles are deterministic, if you have no choice but to live them again exactly as you lived them before, then free will is an illusion. You're an actor reciting lines you'll never be free of, playing a role written in the initial conditions of the Big Bang, destined to play it again and again forever. But if the universe forgets, what remembers? This is the question that haunts cyclic cosmology. If no information persists, if each cycle is a fresh start, then causality breaks down. The next cycle can't be caused by the previous cycle if there's no causal link, no information transfer, no memory. It's not a continuation. It's a coincidence, an infinite series of universes, each arising spontaneously, each happening to have roughly the same laws and constants and initial conditions by sheer chance, except that strains credulity. If each cycle is independent, the odds of them being similar, let alone identical, are infinitesimal. The fact that they cycle at all implies connection, causality, some mechanism that ensures each breath follows the last. So something must remember. Maybe not consciousness, maybe not information in the way we understand it, but something, the shape of space-time, the quantum vacuum, the mathematical structure underlying physical law. Something carries forward, ensures continuity, makes the cycle a cycle rather than a random series. And if something remembers, then maybe you're part of what's remembered, not as thoughts or experiences, as structure, as pattern, as a particular way that matter and energy organize themselves when given certain conditions. You are a recurring motif in the universe's symphony, a phrase that appears again and again, never identical but recognizably the same. If the universe forgets, is anything real? The past is gone. The future hasn't happened. The present is a knife edge, a boundary between what was and what will be, so thin it might not exist at all. If each cycle erases the previous cycle, then reality is always and only now. This breath, this expansion, this temporary flowering of structure and consciousness that will dissolve and return and never know it returned. Reality becomes radical impermanence. Nothing persists. Everything is. And maybe that's the point. Maybe the universe breathes not to preserve but to create, over and over, infinitely, the sheer joy or necessity or accident of existence renewing itself without need for permanence, or memory or meaning beyond the fact of its own. Occurrence. You are both the universe's firstborn and its ancestor, because in a cyclic cosmos, those categories collapse. There is no first. There is no last. There is only the breath, inhale and exhale, contraction and expansion, the eternal now repeating itself with variations too subtle to perceive, or differences so vast that each cycle is its own universe, unconnected to the others except by the mathematics that governs them all. Miss this section, and you'll never reconcile the terror of meaninglessness with the ecstasy of infinity, because they're the same thing. The terror is that nothing you do matters in the grand scheme, that the universe will forget you, that your existence is a fleeting accident. The ecstasy is that nothing you do needs to matter in the grand scheme, that being forgotten is liberation, that existing at all, even once, even briefly, even in an infinite series of forgettings, is the ultimate improbability, the ultimate gift, the universe becoming aware of itself for one shining moment before the breath reverses and awareness dissolves back into potential. Time is a Mobius strip. You walk forever, always arriving where you started, never able to distinguish the inside from the outside because there is no inside or outside, only the continuous surface looping back on itself. Or time is a mirror reflecting a mirror, infinite regress, each reflection containing all previous reflections, diminishing into infinity but never reaching zero. You are standing between the mirrors. You are the image that repeats forever. Each iteration slightly fainter, slightly distorted, but never entirely gone. The universe breathes, and in that breath, for one impossibly brief and infinitely long moment, you exist. Does that comfort you, or does it horrify you? The answer might be yes. You are not in the universe. You are the universe trying to remember how to breathe. This isn't poetry masquerading as physics. This is the logical endpoint of everything we've explored. If matter and energy cycle eternally, if the Big Bang was an exhale preceded by an inhale we can't see, if time loops back on itself through quantum bounces or conformal transitions or brain collisions, then the atoms that make you, the carbon in your cells, the iron in your blood, the calcium in your bones, are older than you can imagine, older than the solar system, older, perhaps, than this cycle of the universe itself. The atoms in your left hand were born 13.8 billion years ago, forged in the nuclear furnaces of stars that lived and died before the Earth existed. But the atoms in your right hand? Maybe they're older. Maybe they passed through a previous cycle, crushed through a big bounce or transformed through a conformal transition, carrying with them some quantum signature, some echo of a universe that ended so this one could begin. You can't tell them apart. They're identical now, indistinguishable hydrogen or oxygen or nitrogen. But their histories might span googles of years, cycles upon cycles, breaths upon breaths, and you, temporary, fragile, improbably conscious you, are where those histories converge. Roger Penrose didn't arrive at conformal cyclic cosmology early in his career. He was already in his 70s when he published the first papers proposing it, an age when most scientists have long since made their major contributions and settled into emeritus status, giving lectures and writing memoirs. But Penrose couldn't let go of a problem. The problem of the singularity, the problem of entropy, the problem of time's arrow and the universe's beginning, and the nagging sense that the standard cosmological model, for all its successes, was missing something fundamental. He'd spent decades working on black holes, on the geometry of space-time, on twistor theory, an attempt to reformulate physics in terms of light rays rather than particles and fields. And somewhere in that work, in the mathematical structures he'd been exploring for 50 years, he saw a way for the end to become the beginning. It was a gamble, a late-career pivot into territory most cosmologists considered speculative at best, misguided at worst. Inflation was the reigning paradigm. tested and confirmed by observations of the cosmic microwave background. To propose an alternative required not just courage, but a willingness to be wrong publicly, to stake your reputation on a theory that might never be confirmed in your lifetime. Penrose did it anyway. He published papers. He gave talks. He searched for evidence in the CMB, found patterns he believed were significant, and endured the skepticism of colleagues who pointed to statistical noise and instrumental artifacts. Some dismissed him gently, with the reverence due to a Nobel laureate whose earlier work was unimpeachable. Others were harsher, suggesting he'd ventured beyond the boundaries of empirical science into mathematical fantasy. But Penrose didn't back down. He refined the model, collaborated with younger cosmologists willing to take the risk, continued searching for evidence. And whether or not his specific predictions are confirmed, he'd already done something important. He'd reopened a question the cosmology community thought was closed. He'd reminded everyone that the Big Bang singularity is a place where our physics breaks, and that broken physics demands new thinking, not comfortable consensus. Paul Steinhardt made a different kind of gamble. In the 1980s, he was one of the architects of cosmic inflation, the theory that the universe underwent exponential expansion in its first fraction of a second, smoothing out irregularities and setting the stage for structure formation. Inflation became the standard model. It explained the horizon problem, the flatness problem, the origin of density fluctuations. Steinhardt was celebrated for it, and then he turned against it. Not because the theory was wrong, it made predictions that matched observations, but because it wasn't unique. Inflation could be tweaked in countless ways, adjusted with different fields and potentials and parameters, making it unfalsifiable in practice. Any observation could be accommodated by some version of inflation. And Steinhardt realized that a theory that explains everything explains nothing. Science requires risk. It requires theories that stick their neck out and can be definitively proven wrong. Inflation had become too flexible, too accommodating. So he pivoted. He developed the ekpyrotic model with Neil Turok and others, a cyclic cosmology based on brane collisions in higher dimensional space. It was a direct competitor to inflation, making different predictions about primordial gravitational waves and the spectrum of density fluctuations. And it was immediately controversial. Steinhardt was accused of abandoning his own successful theory out of philosophical dissatisfaction, of chasing elegance over evidence. Debates became heated. Papers were published attacking the ekpyrotic model on technical grounds. Steinhardt defended it vigorously, arguing that science needed alternatives, that the community had become too wedded to inflation, that intellectual monoculture was dangerous. The controversy continues. Both inflation and the ekpyrotic model remain viable. Observations haven't yet distinguished them decisively. But Steinhardt's willingness to challenge his own earlier work, to risk his reputation on a radical alternative, embodies something essential about how science advances. It's not through consensus and comfort. It's through struggle, dissent, the willingness to be wrong if being wrong leads to deeper truth. These are human stories. Scientists driven by curiosity and frustration, and the same existential questions that keep you awake at night. Why does the universe exist? Where did it come from? Will it end? And if it ends, is that truly final? They've spent lifetimes doing mathematics, running simulations, analyzing data, not because they're detached observers, but because they're deeply, personally invested in the answers. They want to know how the universe breathes. And in pursuing that knowledge, they've become allegories for the universe's own struggle to remember itself. Because if cyclic cosmology is correct, the universe has been here before. It's expanded and contracted, or expanded and transitioned or bounced countless times, and each time it's forgotten. Information is lost or scrambled or encoded in ways so subtle that conscious beings arising in the next cycle can't access it. The universe suffers from cosmic amnesia, doomed to repeat its history without remembering it. Unless consciousness changes that. Unless observers, beings like us, like the scientists dedicating their lives to understanding cosmic cycles, are the universe's way of finally, after infinite repetitions, becoming aware of its own pattern. This is where the anthropic principle becomes profound rather than trivial. The weak anthropic principle simply states that we observe the universe to have properties compatible with our existence, because if it didn't, we wouldn't be here to observe it. That's true but uninteresting, a tautology. The strong anthropic principle suggests something deeper, that the universe must have properties that allow conscious observers to arise, not as an accident, but as a necessity, a fundamental feature woven into the fabric of reality itself. If the universe breathes, if it cycles eternally, then consciousness arising in each cycle isn't random. It's inevitable, given enough time and the right conditions. And once consciousness arises, it can do something the unconscious universe cannot. It can reflect, remember, record. It can look at the cosmic microwave background and see patterns. It can measure the expansion rate and infer a history. It can do mathematics and discover that the Big Bang might not be the beginning. Consciousness is the universe's memory, the one thing that survives not physically across cycles, but functionally, as a recurring capacity, a pattern of self-awareness that emerges whenever complexity reaches a threshold. You are a pattern, not a thing. This is hard to accept. We feel like things, solid, continuous, persistent, but you're not. You're a process, a temporary arrangement of atoms that were cycling through stars and planets and other living beings long before you were born, and will continue cycling long after you die. Your body replaces its cells continuously. The atoms you're made of today are not the atoms you were made of 7 years ago. What persists isn't the matter, but the pattern. The information that says, arrange these atoms this way, and you get a person who thinks and feels and remembers. And if patterns can persist within a lifetime, if you're the same person despite having different atoms, then patterns can persist across lifetimes, across cycles, across the breadth of the universe itself. Not as individual identity. You won't remember being you in a previous cycle, but as archetypal structure, the pattern that generates consciousness, that builds complexity, that looks at the stars and asks why. Recurs because the laws of physics recur. Because the initial conditions, at least in some models, recur. Because the universe, in breathing, follows grooves. It's carved through infinite repetition. But there's one thing the breathing universe can't explain. Why you feel like you. Consciousness is the hard problem. We can describe the brain mechanistically. Neurons firing, synapses forming, electrical and chemical signals propagating. We can map consciousness to brain states with increasing precision. But none of that explains subjective experience, the quail of redness, the taste of coffee, the feeling of being someone rather than no one. Why does the universe, in arranging atoms into the pattern called you, create an inner light, an awareness that experiences itself? Why aren't you a philosophical zombie, behaving identically but experiencing nothing? If the universe breathes, every goodbye is temporary. Death is just a held breath. This might be the most comforting implication of cyclic cosmology, or the most horrifying, depending on how you value continuity of consciousness. Your loved ones will die. You will die. But if the universe cycles, if patterns recur, then the arrangement of atoms that made them, that makes you, will recur. Not immediately, not in the next generation or the next millennium, but in the next cycle, or the cycle after that, or in one of the infinite cycles to come, the conditions will align, and someone indistinguishable from you will exist again. Same memories, same personality, same relationships, because the laws of physics and the initial conditions conspire to recreate you exactly. Except you won't know. There's no thread connecting this you to that you. It's not reincarnation in the mystical sense, where some soul or essence persists. It's reconstitution, a fresh start that happens to be identical to previous starts. Is that comfort? Does it matter that you'll exist again if you can't remember existing before? Is it different from saying that after you die, the atoms that made you will become part of other things? Trees, oceans, other people, which is true regardless of cosmic cycles? Maybe. Because in a non-cyclic universe, the atoms that made you will eventually participate in heat death, locked into maximum entropy, unable to form complex structures ever again. The pattern that is, you will dissolve permanently. But in a cyclic universe, heat death is temporary. The breath reverses. Entropy resets or reframes. New complexity becomes possible. The universe gets another chance to create you and another, forever. You are not eternal in the sense of persisting continuously, but you are eternal in the sense of recurring infinitely. You are the universe's favorite song, played on repeat, each time as if for the first time. This is the section where the universe stops being abstract and becomes you. Because every question about cosmic cycles is ultimately a question about your existence. If the universe breathes, you are part of that breath. If it remembers or forgets, you are what's remembered or forgotten. If it cycles eternally, you have always existed and will always exist. Not as a continuous being, but as a recurring pattern, a motif the universe can't help but return to, because the mathematics and the physics and the initial conditions demand it. Picture a single human breath synchronized with the pulse of a quasar. Your lungs expand. Light years away, a quasar ejects jets of plasma at relativistic speeds, powered by a supermassive black hole consuming matter and converting it to energy. Your lungs contract. The quasar's accretion disk wobbles, precesses, changes brightness on timescales of years. You and the quasar are both breathing, both rhythmic, both temporary structures in an evolving cosmos. The quasar will eventually exhaust its fuel. You will eventually exhaust yours. But the matter and energy that made both of you will persist, will cycle, will contribute to future structures in future times. Maybe in future universes, you contain multitudes, atoms forged in different stars at different times in different regions of the galaxy, now unified in the pattern called you. If those atoms passed through previous cycles, you contain even more, echoes of extinct stars in extinct galaxies in extinct universes, all converging in this moment. This breath, this particular arrangement of matter that looks out at the cosmos and recognizes itself as part of it. We are not witnesses to the universe. We are its memory. This is the rallying cry. The reason cyclic cosmology matters beyond academic debates and equations. If the universe forgets with each cycle, if information is lost at the transition, then consciousness is the only thing that can preserve knowledge across the breath. Not physically. We won't survive the heat death, or the bounce, or the conformal transition. But functionally, by figuring out that the universe breathes, by encoding that knowledge in theories and equations and observations, we're doing something the unconscious universe cannot do. We're remembering for it. We're becoming aware of the pattern it's trapped in. And maybe that's why consciousness exists at all. Maybe the universe doesn't just produce observers as a side effect of complexity. Maybe it needs observers. Maybe in the vast space of possible universes, the ones that survive, that persist through cycles, are the ones where consciousness arises and begins to understand the cycles. Not because consciousness changes the physics, though quantum mechanics suggests observers do play a fundamental role in collapsing possibility into actuality, but because a universe that knows it breathes is different from one that doesn't. It's a universe becoming aware of itself, and awareness, even if it's fleeting, even if it's forgotten in the next cycle, might be the point. You are the universe, trying to remember how to breathe. Every time you inhale, you're participating in a pattern as old as time itself. Every time you exhale, you're releasing matter and energy back into the system, contributing to the cycle. You're not separate from the cosmic breath. You are it, localized, temporary, conscious, and in that consciousness, in your ability to look at the stars and the equations and the cosmic microwave background and piece together the story of where you came from and where you're going, you're fulfilling a role the universe cannot fulfill for itself. You are its memory. Imperfect, brief, but real. And that might be enough. The most honest answer science gives is, we don't know, and maybe never will. That sentence should be liberating, but for most people it's terrifying. We're pattern-seeking creatures. We crave answers, closure, the satisfaction of problems solved and mysteries explained. We want the universe to make sense, to reveal its secrets when interrogated properly with mathematics and instruments and patience. And the universe does reveal secrets, countless secrets, an endless procession of discoveries that rewrite what we thought we knew. But for every answer, 3 new questions emerge. And at the frontier, at the absolute edge of human knowledge where cyclic cosmology lives, the questions multiply faster than answers ever could. Why does the universe breathe at all? If conformal cyclic cosmology or the ekpyrotic model or the Big Bounce is correct, we've replaced one mystery. Why did the Big Bang happen? With another, why do cycles happen? What mechanism ensures the transition from ending to beginning? In Penrose's model, it's a mathematical transformation, a conformal rescaling that maps infinite future onto finite past. But why does nature perform this transformation? Is it inevitable, written into the deepest laws of physics, or is it contingent, one possibility among many that happens to occur in our universe but might not occur in others? In the ekpyrotic model, brains collide because they're attracted through the extra dimension. But why do brains exist? Why is there a bulk, a higher dimensional space our universe floats in? And what determines the timing of collisions, Why every trillion years instead of every billion or every Google? In loop quantum cosmology, the bounce happens because space has discrete quantum structure that prevents infinite contraction. But why does space have this structure? Why these particular equations of loop quantum gravity and not some other quantum theory of space-time? Every cyclic model pushes the ultimate question back one step. But the question remains, why is there something rather than nothing? Why does reality exist at all, cycling or otherwise? And that question might be unanswerable, not because we lack the right instruments or mathematics, but because it's asking for an explanation outside the system when we're stuck inside it. Asking why the universe exists from within the universe is like asking a character in a novel why the novel exists. The character can analyze the plot, the themes, the narrative structure, but it can't step outside the pages and interview the author. Is there a first breath, or has it always been? This question fractures into two equally uncomfortable possibilities. If there's a first breath, a first cycle, a true beginning before which there were no previous cycles, then what caused it? We're back to the Big Bang problem. Something from nothing, or something from some prior state we can't access or understand. If there's no first breath, if cycles extend infinitely into the past, then we face the problem of infinite regress. Causality chains stretch backward forever, with no ultimate cause, no ground of being, just an endless series of cycles each caused by the previous one in an eternal sequence that has no beginning. Infinite regress offends our intuition. We want first causes, ultimate explanations. Aristotle called it the unmoved mover, the cause that itself has no cause. Theology places God in that role, but physics has no place for an unmoved mover. Every cause must itself be caused by prior physical states evolving according to law. If the universe has always been cycling, then causality extends infinitely backward. And we must accept that some questions, like what started it all, have no answer because there was no start. But accepting infinite regress creates its own problems. If entropy always increases, and if information is preserved across cycles in models like the ekpyrotic universe or certain versions of the bounce, then entropy should also increase across cycles. The universe should get progressively more disordered with each breath, carrying forward the entropic burden of all previous cycles. Eventually, entropy would become so high that no new complexity could form. Stars wouldn't ignite, galaxies wouldn't condense, life couldn't arise. The cycles would continue, but they'd be dead cycles, structureless expansions and contractions with nothing interesting happening, unless entropy resets. In Penrose's model, it does, not by decreasing, but by reframing. The conformal transition erases the markers by which we measure entropy. In the far future, when only massless particles exist, entropy in the conventional sense becomes undefined. The next cycle begins from this smooth, low-entropy equivalent state. But this raises another question. Why does the conformal transformation have this effect? Why does nature allow entropy to reset, violating, or at least circumventing, the second law of thermodynamics at cosmic scales? What breaks the symmetry? If cycles are eternal and roughly identical, why is this cycle different from the previous one? Or is it different at all? Quantum mechanics introduces randomness at the smallest scales, virtual particles popping in and out of existence, quantum fluctuations in fields, the irreducible uncertainty of position and momentum. These fluctuations might seed differences between cycles. One cycle might have slightly different initial conditions than another, leading to different structures, different galaxies, different outcomes. Over infinite cycles, every possible variation would occur, including cycles where you make different choices, where civilizations rise and fall in different patterns, where the laws of physics themselves might vary if they're emergent rather than fundamental. But if quantum randomness breaks the symmetry, then no two cycles are identical. The eternal return isn't eternal recurrence of the same, but eternal generation of variations. You might exist in infinite cycles, but never quite the same way twice. Does that make you unique or multiply you into infinity? Are you one person or an infinite ensemble of almost yous, each living a slightly different version of the same life in different cycles? There are more unanswered questions about the universe than atoms in the observable cosmos. That's not hyperbole. The observable universe contains about 10 to the 80 atoms. But for every fact we know, every measured constant, every confirmed theory, there are countless questions we haven't answered, countless phenomena we haven't explained, countless regions of possibility space we haven't explored. What is dark matter? What is dark energy? How does quantum mechanics give rise to classical reality? Is consciousness fundamental or emergent? Are there other universes? Is mathematics invented or discovered? Why do the constants of nature have the values they do? Can information be destroyed? Is time real? What happens inside a black hole? What existed before the Big Bang, if before even makes sense? Each question branches into more questions. Dark matter might be particles, or modified gravity, or something else entirely. If particles, what kind? WIMPs, axions, sterile neutrinos. If modified gravity, which modification? Mond, Tevis, something more exotic? Every answer opens new territory. And at the deepest level, the questions converge on a few fundamental mysteries we've been circling throughout this exploration. The nature of time, the origin of the universe, the role of consciousness, the reason anything exists at all. Not knowing is terrifying. Not knowing is liberating. You get to choose which. The terror comes from realizing we might never have ultimate answers, that we're finite beings in an infinite cosmos, that our lives are spent groping in the dark with flickering candles, trying to illuminate a cavern the size of eternity. We'll die before the mysteries are solved. Humanity might die before the mysteries are solved. The universe might cycle through heat, death, and rebirth infinite times without ever producing a conscious being that figures it all out. But the liberation comes from the same place. If we don't know, if we can't know, then we're free to wonder, to speculate, to imagine. The universe becomes not a puzzle with a solution we haven't found, but a koan, a paradox designed to break linear thinking and induce a different kind of understanding. What is the sound of one universe breathing? Not a literal sound. Space doesn't conduct vibrations the way air does, but a metaphorical sound. The rhythm and pattern of cosmic expansion and contraction, the exhale of the Big Bang, and the inhale we can't yet observe. Can you hear it? Not with ears, but with imagination, with the part of your mind that recognizes patterns across scales, that sees yourself in the cosmos, and the cosmos in yourself, unless the universe isn't breathing at all. What if cyclic cosmology is wrong? What if the Big Bang really was a singular event? The universe began 13.8 billion years ago from a quantum fluctuation or divine fiat, or some mechanism we haven't conceived. and it will expand forever into cold, empty darkness with no renewal, no rebirth, no second breath. What if all the models we've explored, Penrose's conformal cycles, Steinhardt's colliding brains, loop quantum cosmology's bounce, are beautiful mathematics that don't describe reality, elegant solutions to problems nature solved differently or didn't solve at all? That's possible. Science is littered with beautiful theories that turned out to be wrong. Epicycles explained planetary motion elegantly until Kepler and Newton showed the orbits are ellipses governed by gravity. The luminiferous ether explained how light propagates until Michelson and Morley showed it doesn't exist, and Einstein showed it isn't needed. Steady-state cosmology proposed a universe with no beginning or end. Matter continuously created to maintain constant density as space expands, until the discovery of the cosmic microwave background proved the universe evolved from a hot, dense state. Cyclic cosmology might join that list. Might be remembered as an interesting idea that didn't pan out, a possibility that observations excluded, a path science explored and then abandoned when better evidence pointed elsewhere. And that would be fine. That's how science works. You propose ideas, test them, and follow the evidence wherever it leads, even if it leads away from theories you found intellectually or emotionally satisfying. But here's the thing. Even if cyclic cosmology is wrong about the universe, it's right about something deeper. It's right that beginnings are suspicious. It's right that singularities mark the limits of our theories rather than truths about nature. It's right that time might be stranger than our intuition suggests, that the arrow we perceive might be local rather than universal, that the breath metaphor captures something essential about existence even if the literal cycling doesn't occur. Can cyclic cosmology and eternal inflation both be true? This is where things get genuinely strange. Eternal inflation proposes that the inflationary expansion that gave rise to our observable universe is part of a larger, never-ending process. Quantum fluctuations in the inflaton field cause some regions to stop inflating, creating bubble universes like ours, while other regions continue inflating forever. The result is a multiverse, an infinite ensemble of universes with different properties, all embedded in an eternally inflating background. Now combine that with cyclic cosmology. Maybe each bubble universe, including ours, cycles. Maybe the end of our universe's expansion triggers a conformal transition or a bounce that becomes the Big Bang of the next cycle. But the cycles happen within the bubble. The eternally inflating background continues regardless. So you'd have an infinite multiverse where each universe breathes independently, each following its own rhythm, each forgetting its own past while the larger structure persists forever. Or maybe the cycles occur at the multiverse level. Maybe the eternally inflating background itself eventually evolves to a far future state that conformally transitions into a new phase of eternal inflation, resetting the multiverse while allowing individual bubble universes to form, expand, and die within each cycle. Cycles within cycles within cycles. Fractal cosmology where every scale mirrors every other scale. And the question, what's the largest structure, has no answer because there's always something larger. These speculations approach the boundary between physics and metaphysics. They're not meaningless. They're based on serious mathematics and theories like inflationary cosmology and loop quantum gravity that have empirical support. But they're also untestable in practice, maybe untestable in principle. If other bubble universes are causally disconnected from ours, separated by regions of space expanding faster than light, we can never observe them. If previous cycles are erased by conformal transitions or quantum bounces, we can never directly detect them. We're trapped inside our observable universe, our single breath, trying to infer the nature of a larger reality we can't access. Does that make these ideas unscientific? Depends on your philosophy of science. Strict operationalists say yes. If you can't test it, it's not science. But science has always involved inference beyond direct observation. We can't see atoms directly, but we infer their existence from countless indirect effects. We can't visit the core of the sun, but we infer its temperature and composition from models and observations. We can't rerun the Big Bang, but we infer its occurrence from the cosmic microwave background and the abundance of light elements. Science is a balance between empiricism and theory, between what we can measure and what we can infer. Cyclic cosmology and multiverse theories might be at the far end of that balance, but they're not outside it entirely. The Socratic method demands we admit ignorance as a form of wisdom. Socrates famously said, "I know that I know nothing," and used that acknowledgement as the starting point for inquiry. Not knowing isn't failure. It's the recognition that reality is deeper and stranger than our current understanding, and that deeper understanding requires humility, the willingness to question assumptions, the courage to follow logic into uncomfortable places. We don't know if the universe breathes. Maybe we can't know. But the question itself changes us. It forces us to think about time differently, to question the Big Bang's singularity, to recognize that beginnings and endings might be illusions created by our limited perspective. It opens possibilities, that death isn't final, that patterns recur, that the universe has depths we haven't fathomed. And even if those possibilities turn out to be wrong, even if the universe is singular and finite and headed toward eternal cold, we've still gained something. We've expanded our conceptual space. We've imagined alternatives. We've done what conscious beings do best. We've wondered. If you skip this, you'll crave certainty forever. Stay, and you'll learn to love the mystery. Because certainty is comfortable but sterile. It's the end of questions, the closing of doors, the declaration that we've arrived and need search no further. Mystery is uncomfortable but alive. It's the recognition that every answer reveals more questions, that the cosmos is richer than we imagined, that the journey of understanding has no final destination because there's always farther to go, always deeper to dive. The universe might be one breath in a larger organism. What if we're the exhale? What if the observable universe, all 100 billion galaxies spanning 93 billion light-years, is just a tiny part of something incomprehensibly vaster? What if that larger structure breathes too, expanding and contracting on timescales that make our 13.8 billion years look like a femtosecond? What if consciousness, life, galaxies, the whole cosmic drama we're part of, is just the exhale phase, the expansion, and somewhere far beyond our cosmic horizon, the inhale is happening? Matter and energy contracting back toward some central point we can never observe? We can't know, but we can ask. And in asking, we participate in something the unconscious universe cannot do. We wonder, we question, we imagine, we breathe, and in breathing, we mirror the cosmos, or the cosmos mirrors us. And the boundary between observer and observed dissolves into a larger unity, where the universe breathes through us. As us, using our consciousness to contemplate its own existence. A question mark made of galaxies, dissolving into the CMB static. That's where we are, standing at the edge of knowledge, looking out at the unknown, holding questions we may never answer, and choosing, because it is a choice, to find beauty in the mystery rather than despair in the ignorance. The universe breathes, or it doesn't. Either way, we're here, now, asking. And that might be the most miraculous thing of all. The universe might be breathing. Or you might be the universe, pretending to breathe. After everything we've explored, the mathematics of conformal transitions, the colliding brains, the quantum bounce, the circles in the cosmic microwave background, the scientists who gambled their reputations on cyclic cosmology, the philosophical vertigo of eternal return, the unanswered questions that multiply faster than answers, we've arrived not at certainty, but at something more valuable. We've arrived at a deeper way of asking the question, not did the Big Bang happen, but what kind of event was it? Not will the universe end, but what does ending mean in a cosmos that might not know how to stop? Let's retrace the breath we've taken together. We began with the standard story, the one you learned in school if you learned anything about cosmology. The universe exploded into existence 13.8 billion years ago from a singularity of infinite density and temperature, and it's been expanding ever since. That story is true. The evidence is overwhelming, but it's incomplete. The singularity is a red flag, a place where our best physics breaks down and admits ignorance. And the question, what came before, refuses to disappear, no matter how many times we're told it's meaningless. Then we discovered the breath. Penrose showed that the far future ending, smooth, timeless, empty, could mathematically transform into a new Big Bang. Steinhardt and Turok showed that colliding brains in higher dimensions could create cyclic expansions without singularities. Loop quantum cosmology showed that quantum geometry prevents infinite contraction and produces a bounce. These aren't fringe speculations. They're serious physics, extensions of theories that work elsewhere, general relativity, string theory, quantum mechanics, applied to the universe as a whole. They predict observable consequences, even if those consequences are subtle and disputed. We confronted the evidence, or the lack thereof. Penrose's circles in the cosmic microwave background might be echoes of a previous aeon, or they might be statistical noise. The data is ambiguous. The debate continues. We can't observe the Planck scale bounce directly. We can't visit other cycles or parallel brains. We're trapped in our observable universe, one breath in a potentially infinite sequence, trying to infer the pattern from a single data point. We wrestled with the philosophical implications. If the universe breathes, if cycles repeat with you in them, are you eternal or erased? Does eternal return give infinite weight to every moment, or does cosmic amnesia drain existence of meaning? We explored ancient cosmologies that intuited these rhythms millennia before telescopes and equations, Brahma's breath, Buddhist kalpas, Nietzsche's eternal return, and found that modern physics is rediscovering questions that philosophy and theology never stopped asking. We saw ourselves in the cosmos, the scientists dedicating their lives to understanding cycles, the atoms in your body that might span multiple universes, the possibility that consciousness is the universe's way of observing its own breath. You are not a witness to existence. You are existence becoming aware of itself, temporarily, locally, but genuinely. And in that awareness, you're doing something the unconscious universe cannot. You're remembering, recording, searching for patterns that might connect this breath to previous breaths or future ones. We admitted we don't know. Maybe we can't know. The universe might cycle. It might not. Both inflation and cyclic models fit some data, contradict other data, make predictions we can't yet test. The honest scientific answer is uncertainty, and we learn to sit with that uncertainty without collapsing into either dogmatic belief or cynical dismissal. The mystery remains, and that's okay. That's good even, because the mystery is what drives us forward. In the time it took you to watch this, 10 to the 50th atoms in your body were replaced. You are already a new breath. This isn't metaphor. Your body exchanges matter with the environment constantly. You breathe in oxygen, breathe out carbon dioxide. You eat food, break it down, incorporate its atoms into your cells. You shed skin cells, lose hair, excrete waste. The pattern that is you persists, but the substance is constantly renewed. You are a process, not a thing, a wave, not a particle. And on cosmic scales, that process mirrors the universe itself. Expansion and contraction, intake and release, the eternal rhythm of existence renewing itself. So, is the Big Bang just one endless breath? The answer is yes, and no, and maybe, and the asking. That's what makes you human. An ant doesn't ask. A star doesn't wonder. But you do. You look at the cosmic microwave background and see not just static, but a photograph of the infant universe. You measure the redshift of distant galaxies and infer the expansion of space itself. You do mathematics and discover that endings might be beginnings, that time might be circular, that the breath you're taking right now echoes something vaster than you can imagine. The scientific resolution is this: cyclic cosmology remains speculative but profound. It hasn't been confirmed. It might never be confirmed. Better observations might exclude it, or they might support it, or they might leave us in perpetual ambiguity, with multiple models all fitting the data equally well. But even if cyclic cosmology is wrong about the literal mechanics of the universe, it's right about something essential. It's right that the Big Bang singularity is suspicious, that our theories have limits, that time and causality and existence itself are stranger and deeper than our everyday experience suggests. It's a reminder that the universe is not obligated to make intuitive sense to creatures who evolved to hunt and gather on African savannas. It operates on principles we're still learning to grasp, and our current understanding, however sophisticated, is surely incomplete. The philosophical resolution is this: whether the universe breathes or not, you do. Right now, in and out, again and again. You've been breathing since the moment you were born, and you'll breathe until the moment you die. Each breath is automatic yet essential, unconscious yet life-sustaining. You are a breathing creature in a universe that might be breathing too. And whether that's literal truth or poetic metaphor doesn't change the fact of your existence. You are here. Now. Temporary? Yes. Your lifespan is cosmically insignificant. A fraction of the current age of the universe. But also infinite, because the experience of being you, of having subjective awareness, of mattering to yourself and to others, is absolute. It doesn't need to last forever to be real. It doesn't need cosmic significance to have meaning. You are temporary. You are infinite. Both are true. You will die, and the atoms that make you will disperse, and the pattern that is you will dissolve. That's temporary. But the fact that you existed, that for a brief window of cosmic time, there was a particular arrangement of matter that looked out at the stars and wondered, is permanent. It happened. Nothing can make it unhappen. If the universe forgets, if no record survives across cycles, that doesn't erase the reality of your existence now. You are real. Your experiences are real. Your breath is real. And that's enough. This is the last chance to feel the universe's pulse. Don't look away now, because what we've been circling throughout this entire exploration, what every equation and theory and philosophical meditation has been pointing toward, is a simple truth. You are connected. To the Big Bang, yes. The atoms in your body were forged in the first 3 minutes of cosmic expansion. To distant stars, yes. The heavier elements were created in stellar cores and supernovae. To the far future, yes. The energy you radiate will propagate outward forever, or until the heat death, or until the next cycle begins. You are not separate from the universe. You are a temporary localization of it, a brief eddy in the river of matter and energy and space-time that flows from past to future, or from cycle to cycle, carrying information and structure and the astonishing capacity for self-reflection. Breathe in. The universe expands. Breathe out. Stars are born again, again, again. Feel it now. The rise and fall of your chest. The automatic rhythm that sustains you. You've done this thousands of times today without thinking. But think about it now. Feel the air entering your lungs, oxygen diffusing into your bloodstream, carbon dioxide being expelled. That oxygen was released by plants or phytoplankton through photosynthesis, a process powered by sunlight, energy that originated in nuclear fusion in the sun's core, converting hydrogen to helium in a reaction that echoes the nucleosynthesis of the early universe. You are breathing stardust. You are breathing time. You are breathing the echo of the Big Bang. And when you exhale, you release carbon dioxide that plants will absorb, that will participate in the carbon cycle, that might eventually be locked in rock, or dissolved in the ocean, or incorporated into new living beings. Your breath continues beyond you. The atoms you release don't stop. They cycle through the biosphere, the atmosphere, the Earth's crust, and eventually, on timescales of billions of years, back into space as the sun expands into a red giant and engulfs the Earth, dispersing its matter into the cosmos where it will seed new stars, new planets, perhaps new life. Your breath is cosmic. Your existence is cyclical. Whether the universe as a whole cycles or not, you certainly do. You wake and sleep. Your heart beats in rhythm. Cells die and are replaced. Seasons turn. Generations rise and fall. Birth, growth, decay, death, and through it all the breath continues, in and out. The fundamental rhythm that connects you to every living thing, every process that requires exchange with the environment, every system that persists by cycling matter and energy through itself. Maybe the universe does the same on the largest scale. Maybe it breathes through cycles of expansion and contraction. Big bangs and heat deaths or bounces or conformal transitions, each breath lasting trillions of years, but following the same essential pattern you follow thousands of times per day. Or maybe it doesn't. Maybe our universe is singular. unique, headed toward a final ending with no renewal. Either way, the metaphor holds. Either way, existence is rhythmic, cyclical, sustained by exchange and transformation, and the constant dance between structure and dissolution. So when you ask, is the Big Bang just one endless breath? You're not just asking about cosmology. You're asking about the nature of existence itself. You're asking whether reality is fundamentally cyclic or linear, whether time is a circle or an arrow, whether endings are final or transitional. And the answer, the honest, complete answer, is that we don't know yet. But we're asking the right question, and the asking transforms us because it forces us to see ourselves not as separate observers, but as participants in a vast unfolding process that might be cyclical, might be singular, but is certainly astonishing. The universe breathes. Or you breathe, and you are the universe. Or breathing is a metaphor that captures something essential about existence that no equation can fully express. Or all of these are true simultaneously. Different perspectives on the same underlying reality, and the tension between them, the uncertainty, the ambiguity, the irreducible mystery, is not a problem to solve but a feature to embrace, a reminder that reality is deeper than our theories, and stranger than our imagination, and more beautiful than certainty could ever be. Breathe in the strangeness. Breathe out the wonder. And again, and again, and again. For as long as you're here, for as long as the universe grants you this particular arrangement of atoms, this particular window of consciousness, this particular breath among infinite breaths, fleeting and eternal, insignificant and precious, one moment in a cosmos that might never stop breathing, exhaling stars and galaxies, and you, inhaling entropy and endings and the seeds of new beginnings, forever or just once, and either way, you are here now, feeling it, asking it, being it, the universe recognizing itself through you, through this breath, this moment, this eternal exhale that began 13.8 billion years ago, or infinite eons ago, or always, or never, or yes,